Welcome back. We're here to talk about 3D shapes today. They're called solids, and some of you made some beautiful models on Friday. Solids are kind of split up into two groups. A polyhedron is when everything's made of polygons, and non-polyhedron are made of, let's say, circles or something, some curves to it. We've got the convex, meaning there's no indents, no bare caves. The concave, there would be little corners that are dented in. We're going to talk about the different types that we'll be studying this chapter. The first is a prism, and one thing that I'm going to ask you to do is be able to draw a prism. Now, a prism is made up of two congruent shapes. Maybe we'll just make a pentagon. So I'm kind of drawing this pentagon like it's sort of laying down on its side. And now the real test is if I can draw another congruent pentagon to be the other base of this prism. I did my best. So if you draw two congruent shapes and then just connect the corresponding vertices, you should have a decent looking prism. And some people like to dot the lines that wouldn't be seen. I didn't do that for all of them, but some of the background ones could be dotted. A pyramid, same idea, except there's only one base. So you'll draw a shape. I like to just put a dot above it, and then everything connects to that one dot. Pyramids just have one base, and every vertex of the base connects to that other vertex. A cylinder, I like to just draw a circle, and I know these look like ovals, but they're supposed to be sort of 3D, so they're flattened out. So draw two congruent circles, connect along the edges, should look like a cylinder. Same thing with a cone, make your bottom piece sort of an oval. Just like the pyramid, put a dot at the top, and connect. It's going to make things easier if you can kind of sketch these out. A sphere, kind of hard to draw in 3D, so just start with a circle and kind of draw in the equator as if you were drawing a globe. Good enough. So these are the types of solids that we're really going to study. Another type of solid that is worth mentioning, because they're amazing, is the Platonic solids. There are only 5 of them, and we made all 5 on Friday. The special thing about Platonic solids is that every single side is congruent. And not only that, every single side is a regular polygon. So here we've got the regular pentagon. Turns out you can hook up 12 of those and make a dodecahedron out of regular pentagons. That's one of the Platonic solids. We've got equilateral equiangular triangles, 4 of them. Make this tetrahedron, 8 of them. Make this octahedron, and 20 of them make this icosahedron. And then the only other regular polygon that can even make a solid like this is the cube. And that has 6 faces that are each squares. They're regular quadrilaterals, right? So 6 squares make a cube. So those are the Platonic solids. Lovely, amazing Platonic solids. Next, let's talk about naming solids. So all these top ones are supposed to be prisms. And so that means that we should be able to find 2 congruent bases connected by their vertices. So this very first one, can you see the 2 congruent shapes? Would be the top and bottom, and maybe those are trapezoids. They kind of look like trapezoids to me, connected at each vertex. And so I would call this a trapezoidal prism. That's all it takes. You just have to find the congruent shapes and name it after the base. So on this one, you might be tempted to call this a rectangle on the bottom. This one's actually just tipped over. Remember, you need to find the 2 congruent bases. That's connected. So this is a triangular prism. This one, our bases are pentagons, so pentagonal prism. Maybe this one is a rectangular prism. And this one has triangles at the top and bottom, so another triangular prism. This one's sort of not standing up straight, it's sort of tipped over. They call that oblique. The rest of these are standing up straight at right angles, so these are all right prisms. This one's an oblique prism. Oblique. It just kind of means standing over in a slanted sort of way, not at right angles. These bottom ones are all pyramids. We've got maybe a square pyramid, a hexagonal pyramid. I think this has 7 sides, so heptagonal. And what is that? I'm going to say 10, a decagonal pyramid. You just need to count the sides on that base, and that's how you will name them. Euler's theorem is what the formula was that some of us learned about on Friday. It's called Euler's theorem. Yes, I'm pronouncing that right. It's a mathematician, Leonard Euler. It says that the faces plus the vertices, the number of faces plus the number of vertices, is going to equal the number of edges plus 2. So if we just work on this Platonic solid, this cube, the faces are the flat pieces, the plane faces. And so on a cube, if you think dice, there are 6 faces. Vertices are just the corners, and if you sort of count them in a systematic way, you'd get 4 on the top, and then the 4 on the bottom. That's 8. And same thing with edges. You want to be sort of systematic about it. The edges are just sort of the fold lines. So we've got 4 at the top. You'd have a matching 4 at the bottom. And then these 4 around the sides. So it's that 4, 4, and 4, 12. And let's just check to see if that works. Do the faces plus the vertices equal the edges plus 2? Yeah. And so that'll always work as long as you have a polyhedron. Cross sections are when you start slicing things up. And so when you have 3D things, for example bread, if you slice it the normal way, you get a cross section that looks like a slice of bread. If you sliced the loaf of bread a different way, maybe this way, you'd have a big long rectangle. And so just think about slicing things and what shape would show up when you were done. A pencil often has a nice hexagon cross section. A piece of celery might have this sort of moon-shaped thing. Normally when you cut down a tree, it's a circle, unless you cut it at a slanted angle. So it kind of depends on what angle you're cutting 3D things at to tell what the cross-section might look like. This one has an oval cross-section or an ellipse. If you cut the cylinder vertically, you might get a rectangle cross-section. If you cut it straight across like a tree trunk, then you'll have a circular cross-section. Spheres, looking very circular. If we cut this pentagonal pyramid, as long as we're cutting parallel to the base, we should just get another pentagon, right? And you can think of slicing that other ways, but these are called cross sections. Think of slicing in what 2D shape would you see when you slice something 3D? If you could just work on this for me then, check out the assignment in the book, and I'll see you back here tomorrow.